Hello students, good afternoon. So in this lecture I am going to discuss about the rectifier part, the classification of rectifier, half wave rectifier and full wave rectifier. What is the construction of and circuit symbol of half wave rectifier and full wave rectifier with its working principle, which is very important to understand. Then we'll discuss about how to find out IDC and IRMS of half wave rectifier as well as in case of full wave rectifier. Then we'll talk about efficiency of half wave rectifier and full wave rectifier. Why the efficiency of full wave rectifier is higher as compared to half wave rectifier, almost two times. And then we'll solve some numerical based on the efficiency and the RMS current and DC current, right? So without wasting the time, we'll start the session. So my name is SR Tusti and you are watching my beautiful channel Love You Science. So let's start. Rectifier is a device. याद रखना, rectifier is a device which convert AC to DC. That is the definition. Rectifier, it is an electronics device which convert AC to DC. Is it clear? So it converts alternating voltage to direct voltage or AC to DC. That is the definition. Again, I repeat, rectifier is a device which converts AC to DC. That is all about the definition. Then rectifier are two types. One is half wave rectifier and second is your full wave rectifier. Okay, याद रखो एक चीज. Again, full wave rectifier are two type. One is center tap rectifier and second is breeze type rectifier. Breeze type rectifier. Again, I repeat, rectifier are two type: half wave rectifier, full wave rectifier. And full wave rectifier are two types: center tap and breeze type rectifier. कैसे याद रखो? देखो, half wave rectifier में only you will be using one diode, only one diode. But full wave में you can use two diode or four diode. If it is center tap, it will be two diode. If it is breeze type, it will be four diode. ऐसे याद रखो. I repeat again, rectifier are two type: half wave, full wave. Half wave में एक diode है, full wave is two type: center tap and breeze type. Center tap में दो diode, breeze type में four diode. Is it clear? So now we go to half wave rectifier first. So half wave rectifier. ठीक है? So what is the circuit diagram? The circuit diagram is, so here one transformer is there. ट्रांसफार्मर का काम होता है स्टेप अप करना और स्टेप डाउन करना. So here the work of transformer is step down the voltage. Here input voltage is AC. So we are connecting one diode here, only one diode, right? And we will be getting output across the load resistance. This is called RL, load resistance. Clear? So output voltage will be getting here. And this is our input voltage, VI. Okay, so we use a step down transformer here. इसका काम क्या है? It will step down the voltage, so we can consider this one as your input voltage, but magnitude is less, right? So we'll be discussing what is the operation of rectifier, half wave rectifier from this end only. So ये supply क्या है? AC और DC? AC. So AC में दो साइकिल होता है, एक पॉजिटिव हाफ साइकिल, एक नेगेटिव हाफ साइकिल. So during positive half cycle, if positive is connected to P terminal of the diode and negative terminal is connected to N to the diode, so it will act as forward biased, right? And next second half cycle में ये negative हो जाएगा, ये positive हो जाएगा. So negative is connected to P and positive is connected to N. मतलब second half cycle में reverse bias हो जाएगा. मतलब first half cycle positive is connected to P and negative is connected to N, it will be forward bias, then conduction takes place, then current can flow. If current can flow, then voltage will be dropped here, V naught we can get, right? The nature will be same. Okay, so during second half cycle, so negative is connected to P and positive is connected to N, so it will be reverse bias. Then current will be how much? Zero. It will act as open circuit. मैंने बोला था resistance will be infinite in case of reverse bias. So current will be zero. In case of forward bias, resistance will be zero. Current will be maximum. Is it clear? Next, what is the wave form here? So I'll erase this one. ओके ये अगर आपका इनपुट वोल्टेज है, ये आपका इनपुट वोल्टेज, सप्लाई फ्रीक्वेंसी कितना है 50 हर्ट्ज। ओके ये इनपुट वोल्टेज, ये पॉजिटिव हाफ साइकिल, ये नेगेटिव हाफ साइकिल, राइट। So let this one is your output voltage. So during positive half cycle, if forward bias or reverse bias, forward bias, then current can flow through the external resistance, then voltage will drop. So that means you'll be getting same nature of voltage over here. But during negative half cycle, मतलब ये diode conduct हो रहा है. But during negative half cycle, it will be reverse bias. Current will be zero. Then current through the resistance, output resistance to load resistance will be zero. Then voltage will be zero. So here voltage will be how much? Zero. So diode will not conduct over here in the negative half cycle. Is it clear? In positive half cycle diode conduct, you can write down. Negative half cycle diode does not conduct. Okay, it is clear. Similarly ये positive half cycle, ये negative half cycle. Positive half cycle में ये conduct हो रहा है, negative में conduct नहीं हो रहा है, right? So मतलब if supply frequency is f here also this is nothing but pulsating DC. You can say it is pulsating DC. It is not pure DC. As our topic is rectifier, it will convert to AC to DC. So here it is complete AC, but this one is pulsating AC. Some portion is zero, some portion has some magnitude, positive magnitude. So that means we are eliminating the negative part. So it is called pulsating DC, right? Then by using the filter circuit, we can get the steady part. If we use the filter circuit, we can get the resultant steady part, right? So if it is pulsating DC, it has a frequency. Don't say it has zero frequency. If it is final DC, then frequency will be zero. Since input has frequency f, so pulsating DC में देखो complete cycle में इतना आ रहा है. So ये time period same है, तो frequency will be same. So input frequency will be equal to the frequency of pulsating DC. Then after connecting filter, you will be getting a steady DC, which has frequency 0. So that is all about half wave rectifier. Clear? Now I will discuss about full wave rectifier. Full wave rectifier. As I have told, full wave rectifier are two types. One is bridge type, one is center tap, second is bridge type. So first we will discuss about center tap rectifier. Center tap rectifier में दो डायोड यूज होता है, ठीक है. सेम थिंग, here input side is AC, so we are using a step down transformer. This is your input side AC, we are using a step down transformer, and we have two diode connected like this, diode D1 and diode D2, right? And we are making it short, and ये tapping हो रहा है center से, and we are connecting a load resistance here, and we'll be measuring the output voltage at the load resistance. Is it clear? Is it clear about circuit diagram? See here input voltage is let it be 230 volt. We are using a step down transformer which will step down this AC voltage, right? So ये भी AC voltage. So now from this end we will consider. So ये भी AC voltage है, right? So during the positive half cycle, ये tapping का मतलब, tapping is a different concept you will be studying in magnetism. और like tapping मतलब क्या होता है ना, as you know number of turn in a coil is directly proportional to EMF induced. अगर सेंटर से टैप हो रहा है तो वोल्टेज इक्वली डिवाइड हो जाएगा. सो ये अगर पॉजिटिव है, ये नेगेटिव है हमारा AC सप्लाई. सो जहां पे टैपिंग हुआ ये नेगेटिव हो जाएगा, ये पॉजिटिव हो जाएगा. मतलब ड्यूरिंग पॉजिटिव हाफ साइकिल, लेट अस ड्रॉ द ग्राफ, दिस इनपुट वोल्टेज, ये पॉजिटिव हाफ साइकिल. ड्यूरिंग पॉजिटिव हाफ साइकिल ये प्लस है, ये माइनस है. Plus is connected to D1, so it will be forward bias. Minus is connected to D2, it will be reverse bias. Clear? So मतलब ये open हो जाएगा, reverse bias. So current will flow like this. If current will flow, voltage will drop. So that means in first half cycle, diode D1 conduct, and we are getting some voltage as same nature. But during negative half cycle, में क्या हो जाएगा देखो, अगेन दिस पार्ट ये क्या था, नेगेटिव था. सो अभी नेगेटिव हाफ साइकिल में ये माइनस ये प्लस हो जाएगा. इफ इट इज माइनस इट विल बी प्लस, इफ इट इज प्लस इट विल बी माइनस. टैपिंग में जस्ट अपोजिट पोलैरिटी डेवलप हो जाए होगा, ठीक है. सो नाउ positive terminal is connected to D2 and negative terminal is connected to D1. So D2 will be forward bias and D1 will be reverse bias. If it is reverse bias, it will be open, right? No current will flow. So current का flow इधर होगा through this diode to the load resistance. So यहाँ पे voltage drop होगा V. So मतलब we will be getting the same nature, right? So during positive half cycle में conduct हो रहा है D1, we are getting some output voltage. During negative half cycle में another diode is conduct, then current flows through the load resistance, again we are getting some voltage, right? Same voltage, same magnitude of voltage. So ASS cycle होगा D1 D2, right? Is it clear? So एक note down a point. First half cycle, during positive half cycle में क्या होगा? D1 conduct होगा, D1 conduct, then current can flow, but D2 क्या होगा? Does not conduct, so current will be zero, right? So D2 will be open circuit, ये open circuit हो जाएगा. ये हो गया during positive half cycle. But during negative half cycle में क्या होगा? Negative half cycle में D2 conduct, because ये positive हो गया ना, positive is connected to D2, D2 conduct होगा. अगर D2 conduct होगा, then current can flow through the load resistance, right? And D1 does not conduct, D1 does not conduct, so current will be zero here. So D1 will act as open circuit here. So again I repeat, this is D1 and D2. During forward biased ये positive था, so positive is connected to P and ये negative था, negative is connected to P of D2, so it will be reverse bias, it will be forward bias. So current का direction इस तरफ होगा, ये तो reverse bias मतलब open हो जाएगा. So यहाँ पे voltage drop होगा, ये देखो voltage drop हुआ, ठीक है. And during negative half cycle ये minus हो जाएगा, ये plus हो जाएगा. Minus is connected to P, so it will be reverse bias. Plus is connected to P of D2, so it will be forward bias. So current भी flow होगा इस तरफ. Then again voltage drop होगा, देखो D2 across through D2 across RL. Is it clear? So during positive half cycle, this diode का internal resistance we are considering as 0. So during positive half cycle, D1 will be short circuit and D2 will be open. During negative half cycle, D2 will be short circuit, current will flow and D1 will be open. So what you conclude here, so it is your pulsating DC. Which DC? Pulsating DC. So if supply frequency is AF, what is the frequency of pulsating DC? It will be 2AF, याद रखना. Frequency क्या होता है? Number of cycle per second, right? So देखो, ये अगर सप्लाई फ्रीक्वेंसी f होगा, ये पल्सेटिंग डीसी का आउटपुट फ्रीक्वेंसी विल बी 2f. देन आफ्टर कनेक्टिंग ए फिल्टर यू विल बी गेटिंग व्हाट? फिक्स्ड डीसी. फिक्स्ड डीसी का फ्रीक्वेंसी कितना है? फ्रीक्वेंसी विल बी 0. सो दैट इज ऑल अबाउट द प्रिंसिपल ऑफ फुल वेव रेक्टिफायर. सेंटर टैप फुल वेव रेक्टिफायर. देखो सेंट्रली वी आर टैपिंग दिस वन, द सेकेंडरी साइड. टैपिंग का मतलब होता है जस्ट वाइंडिंग को दो पार्ट में डिवाइड कर दो. तो यहाँ पे जो भी पोलैरिटी होगा यहाँ पे ऑपोजिट होगा, ये माइनस हो जाएगा, राइट? ये अगर माइनस है, ये प्लस है. सेकेंड हाफ साइकिल में ये माइनस, ये प्लस, ये प्लस, ये माइनस. ओके, सो नाउ वी विल डिस्कस वेरी इंटरेस्टिंग एंड इम्पोर्टेंट पार्ट, that is full wave bridge type rectifier. The constructional, the circuit symbol, how to draw the circuit diagram of full wave bridge type rectifier, and what is the working principle. ये थोड़ा ट्रिकी है. As I have told that how many diodes will be connected? 4 diodes, right? So एक ट्रिक बोल रहा हूँ कैसे सर्किट डायग्राम बनाओगे. right? इसका नाम दे दो, 4 पॉइंट ले लो, A, B, C and D, right? थ्रू A एंड C एक डायोड कनेक्ट करो, इसका नाम दे दो D1, राइट? थ्रू C टू D लोड रेजिस्टेंस कनेक्ट करो, जहां से हम लोग मेजरमेंट करेंगे आउटपुट वोल्टेज. थ्रू इसका जस्ट ऑपोजिट है, सेम टाइप ऑफ पोलैरिटी डायोड दे दो, लाइक योर लेट इट बी D3, राइट? अगेन फ्रॉम C टू B एक डायोड कनेक्ट करो इन ऑपोजिट पोलैरिटी, लेट इट बी D2. यहाँ पे भी सेम थिंग, ऑपोजिट पोलैरिटी, लेट इट बी D4. नाउ you connect this AB terminal will act as input voltage. So then एक ट्रांसफार्मर कनेक्ट कर दो, एक ट्रांसफार्मर लगा दो इधर, so it will act as our input voltage. ये तो ट्रांसफार्मर का कुछ काम नहीं, it will just step down the voltage, that's all. So we'll discuss this entire operation of full bridge type rectifier from this end only, not from this end, right? So what will happen, see, ये हो गया आपका इनपुट वोल्टेज V input. So during positive half cycle, what will happen? It will act as plus and a minus. Plus is connected to the P of D1 at the same time N of what? D4. मतलब ये फॉरवर्ड बायस होगा, ये फॉरवर्ड बायस हो जाएगा, ये क्या हो जाएगा? रिवर्स बायस. Is it clear or not? So मतलब it will act as open circuit. So करंट का फ्लो कैसे होगा? देखो, through this, again through this diode. यहाँ देखो, ये पॉजिटिव करंट इज कनेक्टेड टू एन ऑफ D2, मतलब ये रिवर्स बायस हो जाएगा, ये भी रिवर्स बायस. इज इट क्लियर और नॉट? देन करंट का फ्लो कैसे होगा? थ्रू द लोड रेजिस्टेंस. ये पॉजिटिव करंट, अगेन पॉजिटिव करंट इज कनेक्टेड टू P of D3, सो ये क्या हो जाएगा? फॉरवर्ड बायस, राइट? सो करंट फाइनली पॉजिटिव करंट विल रीच टू नेगेटिव. सो इसका करंट का डायरेक्शन कैसे होगा? देखो, फ्रॉम द सप्लाई साइड, देन थ्रू D1, देन थ्रू R, देन थ्रू D3, देन टू नेगेटिव. So that means what you conclude, during positive half cycle D1 and D3 will conduct and D4 and D2 does not conduct. Is it clear? Then since D1 and D3 conduct, so anyhow we are getting current through the load resistance, will be getting some output voltage. So that means this one is your output voltage. It is clear? ये हो गया during positive half cycle. During positive half cycle. Similarly, during negative half cycle क्या होगा? देखो, ये तो डायोड का कनेक्शन था, ओरिजिनल कनेक्शन. Let us draw the diagram. Let us erase this part. Okay. Just a minute. ये आपका D1, ये क्या था? आपका D2 था, ठीक है? ये सब इरेज कर रहा हूँ, ये लोड रेजिस्टेंस, ये सब इरेज कर रहा हूँ, ठीक है? ये फॉरवर्ड बायस, इसको इरेज कर रहा हूँ, ठीक है? Now we'll see. During the negative half cycle, it is minus and this one is plus. So we'll take from this side only. The positive terminal is connected to the P of D2, मतलब ये forward bias हो जाएगा. So at the same time, the positive terminal is connected to N of D3, मतलब ये reverse bias हो जाएगा. अगर ये reverse bias हो जाएगा, it will act as open circuit. Current will not flow, conduction current will not flow. So current का डायरेक्शन कैसे होगा? देखो, through this हो गया डायरेक्शन ऑफ करंट. Then here positive terminal is connected to N of D1, मतलब ये रिवर्स बायस हो जाएगा, ये रिवर्स बायस हो जाएगा. So it will act as open circuit. So by default current will flow through load resistance. Yes or no? And again same positive terminal is connected to anode of or P layer of D4. So it will act as forward bias or reverse bias? Forward bias, मतलब करंट का डायरेक्शन इस तरफ होगा. So that means the entire current will flow first through D2, then through load resistance, then through D4, then finally coming to negative terminal. So since current is flowing to the right side direction as earlier, so here D2 and D4 will be forward bias. So current the magnitude of voltage will be looks like this. So मतलब ये फर्स्ट हाफ साइकिल में और ड्यूरिंग पॉजिटिव हाफ साइकिल में D1 D3 कंडक्ट्स and negative half cycle में D2 and D4 conducts. Similarly process will continue. ये D1 D3, ये D2 D4. So इसको बोलते हैं क्या है? pulsating DC. क्या है? pulsating DC. अगर इसका सप्लाई फ्रीक्वेंसी f होगा, ये फ्रीक्वेंसी कितना होगा? 2f. So after connecting a filter, we'll be getting fixed DC. Fixed DC. इसका फ्रीक्वेंसी कितना होगा? 0. So that is all about the working principle of full bridge type rectifier. It's very important to remember the circuit diagram. Once you able to draw the circuit diagram, then it will be quite easy to draw the waveform, and you can write the principle. Very simple. In positive half cycle, D1 D3 will forward bias, D4 D2 reverse bias. कोई भी अगर डायोड रिवर्स बायस होगा, make it open. If it is forward bias, make it short, right? And during negative half cycle, same thing. D4 and D2 will be forward bias, and D1 D3 will be reverse bias. So I'm writing here. So point number 1, during positive half cycle, D1 D3 forward bias, D2 D4 क्या है, reverse bias. Done. So during negative half cycle, ये D2 D4 forward bias and D1 D2 D3 क्या है, reverse bias. ठीक है. So during forward bias current conducts होगा, reverse bias में current जीरो होगा, open circuit. forward bias में current maximum और short circuit होगा, reverse bias में current क्या होगा, जीरो होगा. I think it is clear. So now we'll be discussing about the current and efficiency of half wave rectifier and full wave rectifier. Current and efficiency of half wave rectifier and full wave rectifier. देखो, first we'll discuss about half wave rectifier. हाफ वेव रेक्टिफायर में आपका जो इनपुट था, ये इनपुट था, दैट इज योर इनपुट वोल्टेज, बट ओनली पॉजिटिव हाफ साइकिल में डायोड इट इज कंडक्टेड, राइट? सो विल बी गेटिंग दैट काइंड ऑफ पल्सेटिंग डीसी. ऑलरेडी हैव टोल्ड यू, ये हो गया आउटपुट वोल्टेज. दिस इज कॉल्ड पल्सेटिंग डीसी. मतलब डायोड ओनली कंडक्ट इन फर्स्ट हाफ साइकिल. So how to find out current? Current you can say one is IDC, इसको बोलते हैं I average, and second is IRMS. RMS मतलब root mean square current, right? So first we'll find out IDC. How to find out IDC? So we have to integrate this function. What is the input voltage? What is the equation of input current? I is equal to Im sin omega t. That is the standard equation, right? To find out IDC, we have to integrate this function from 0 to pi. We have to integrate this function from 0 to pi, right? And to get the mean, we have to divide 2 pi. ये important, याद रखना. We have to integrate this function from 0 to pi, but to get the average value or DC value, we have to take that entire part. That means we have to divide 2 pi. So since we are integrating this function with respect to d omega t, right? So Im will by 2 pi, तो कॉमन आ जाएगा, integration of sin omega t. What is integration of sin omega t? It will be cos omega t from 0 to pi, right? So it will be Im by 2 pi minus of cos pi minus of cos 0, right? Clear? So it will be Im by 2 pi minus cos pi is minus 1, ये minus cos 0 is again 1, right? So that entire part will be 2. So it will be Im by 2 pi into 2. 2 will be cancelled. So your IDC will be Im by 2 pi. Most important, याद रखना है. The IDC will be Im by 2. Sorry, not Im by 2, Im by pi. Is it clear? So ये हो गया IDC. Similarly, to find out the IRMS, what we'll do? To find out IRMS, RMS मतलब root means square. So we have to take the square of that function first, then we'll take the mean, and then we'll take the root. So same thing, we'll take the square of that function, Im square sin square omega t, sin square omega t, right? And we'll integrate this function from 0 to pi to get the mean. To get the mean, we have to divide what? 2 pi, I have told. Then we'll take the root, right? So root mean square का मतलब क्या है? First you take the square of individual term, then you take mean, then you take root. So our standard equation is Im sin omega t. So we have to integrate. We have to take the square of that equation, which will be Im square sin square omega t, and we'll integrate this function from 0 to pi. To get the mean, we have to divide 2 pi since we are considering this portion. Then we'll take the root. Okay. So here it will be Im square by 2 pi and integration of what? Sine square omega t into d omega t from 0 to pi root, right? So sine square theta is nothing but 1 minus cos 2 theta by 2. So I can write down in place of sine square theta 1 minus 2 theta 1 minus cos 2 theta by 2, right? So that means we are integrating this function from 0 to pi with respect to d omega t, and then here it will be Im square by 2 pi then under root, right? It is clear? So here I am writing, so 1 by so that means it will be Im square by 2 pi, then 2 को इधर ले आओ, it will be 4 pi, right? Then 1 into d omega t integration from 0 to pi, okay, minus integration of how much? Cos 2 omega t from 0 to pi into d omega t, right? Is it clear? So ये पूरा function हो गया, then you take the root, okay? Then what we'll do, Im square by 4 pi, 1 integration of d omega t is omega t, so your limit will be from 0 to pi, clear? Minus cos 2 theta का integration is anyhow sin 2 theta, okay? Sine of 0 is 0, sine of pi is 0, so this part will be 0, right? So that means we'll be getting Im square by 4 pi omega t of limit 0 to pi under, right? So it will be Im square by 4 pi, pi minus 0 under root. So our final answer will be ये pi will be cancelled, so Im square का under root Im and 4 का under root क्या है 2. So IRMS is nothing but Im by 2. It's very important. Im by 2. It is clear? Okay. So next, in case of full wave rectifier, what is the value of IDC? See, in case of full wave rectifier, this is our input and this is our output. Sorry. Okay, this one is your output. So that means in each cycle, positive half cycle में conduct हो रहा है, negative half cycle में भी conduct हो रहा है. Since we have talking about full wave rectifier, right? So again, here you will be getting two current. One is IDC, second is what? IRMS. Root means square value and IDC or average value. So to find out IDC, what you will do? Again, you have to write this instantaneous equation Im sin omega t. You have to integrate this function from what? Again 0 to pi, not 2 pi, 0 to pi, because we are getting output. ये हो गया pulsating DC, and in each cycle we are getting the output. So we have to integrate this function Im sin omega t from 0 to pi, right? And we'll divide 1 by pi to get the average value. Why? Because in this case we are getting 2 cycle. अगर इसका frequency f होगा, इसका frequency कितना है 2f. That means to get the average value or DC value, we have to integrate this function from 0 to pi and divide pi. So that means it will be Im by pi sin omega t integration is minus of cos omega t and limit is from 0 to pi, right? So it will be Im by pi, ये minus of cos pi by minus of cos 0, okay? So that means it will be Im by pi minus 1 minus 1, it will be 2 Im by pi, right? So it will be 2 Im by pi. Clear? So IDC is nothing but 2 Im by pi, 2 into maximum value of current by pi. Clear? Similarly, to get the RMS current for full wave rectifier, so we'll have to take the square of that instantaneous equation, which will be Im square sin square omega t, and we take the first we take the square, then we take the mean. Matlab you have to sum that quantity from 0 to pi, and to get the mean you have to divide pi, then finally we'll take the root, right? So ये क्या हो जाएगा, देखो Im square by pi, ये तो कॉमन आ जाएगा. Sin square theta is nothing but 1 minus cos 2 theta by 2, so I can write down 1 minus cos 2 omega t by 2 integration with respect to d omega t. बार बार बोल रहा हूँ, we are integrating with respect to d omega t from 0 to pi, then under. It is clear? So ये 2 इधर आ जाएगा, so it will be Im square by 2 pi, ठीक है. So 1 into d omega t integration minus of cos 2 omega t into d omega t integration from 0 to pi. Here it is from 0 to pi, right? Then total root. It is clear? So finally what we will get here, Im square by 2 pi, okay. d omega t का इंटीग्रेशन क्या है, ओमेगा टी, so limit is from 0 to pi under root, and this part will be 0 because cos 2 omega t integration is sin, इसका integration you will be getting in terms of sin form. Sin of 0 is 0, sin of pi is 0, so the entire part will be 0. So here it will be Im square by 2 pi into how much, pi under root, so pi will be cancelled, so it will be Im by root. So RMS value, so the RMS current will be Im by root 2. It is clear? Okay. Now we'll discuss about what is the efficiency of half wave rectifier. ठीक है, efficiency का मतलब क्या होता है, आउटपुट पावर बाय इनपुट पावर into 100. ये हो गया the standard expression of efficiency. Output power by input power into 100. So what is output power? Tell me. So if as I have told, ये अगर आपका इनपुट वोल्टेज है तो आउटपुट will be you are getting in positive half cycle only, right? ये हो गया आउटपुट. So आउट पावर क्या है, पावर होता है I square into R, that is पावर. अगर ये आपके पास हाफ वेव रेक्टिफायर में, let the diode resistance, internal diode resistance is, let it be RF or small r. Small r is the diode resistance, okay, and the capital R is the load resistance. क्या है, load resistance, okay. So output power क्या होगा, the I square into R, because output power you will be getting across the load only. So what is output power, I square into RL. ये जो I square होगा it will be I DC square. Is it clear? ये load resistance is nothing but RL. Power का formula होता है I square into R. Since it is output side, we will be considering I DC square into RL. It is clear? By what is the input power? Input power is nothing but I RMS square, I square into R, but here R is nothing but total resistance, RL plus smaller diode resistance as well as your load resistance. See, ये हाफ वेव रेक्टिफायर का डायग्राम है कि नहीं, ये हाफ वेव रेक्टिफायर का डायग्राम है. ये मान लो कि ऐसे सप्लाई है, यहाँ से आप आउटपुट देख रहे हो, ये लोड रेजिस्टेंस है, ये आपका डायोड रेजिस्टेंस है. सो इफ आई से व्हाट इज द इनपुट पावर, इनपुट करंट इनटू रेजिस्टेंस, योर टोटल रेजिस्टेंस कितना है, R प्लस R, स्मॉल r प्लस कैपिटल RL, एंड व्हाट इज द करंट, IRMS. सो पावर का फॉर्मूला क्या होता है, I square into R, so IRMS into total resistance. But what about output power? You are getting output power only in output side, so power is I square into R, So here I is IDC, so IDC स्क्वायर इंटू RL, याद रखना है चीज, ठीक है। ये हो गया एफिशिएंसी का स्टैंडर्ड फॉर्मूला। सो आई एम इरेजिंग दिस पार्ट, ठीक है, डन। ओके, सी आईडीसी क्या था, याद है मैंने बोला था आईडीसी, आईडीसी इज नथिंग बट IM by pi, that square into how much RL by what is IRMS था, IRMS nothing but IM by 2 इसका स्क्वायर into RL plus smaller. It is clear? It is clear? Okay, so here I am writing, so here IM square will be cancelled, right? So your answer will be RL by pi square by by 1 by 4 into RL plus smaller. It is clear? So that means, so it will be RL by pi square into 4 by RL plus smaller, right? Okay, so I can write down here 4 by pi square into RL by RL plus R. So 4 by pi square is 3.14 whole square into RL by how much? RL plus smaller. So this part, if you solve, I think it is coming 0.406 into RL. You can calculate here RL by RL plus R. It is clear? So ये हो गया standard formula of efficiency. So now to get the maximum efficiency, we can consider diode resistance will be 0. Let diode resistance will be 0. Then RL will be cancelled. Then what is the maximum efficiency? Tell me. 0.406 into 100. So it will be 40.6%. So the maximum efficiency of half wave rectifier is 40.6%. क्लियर है कि नहीं, ना कुछ डाउट है इसमें? इट्स वेरी सिंपल, आउटपुट पावर बाय इनपुट पावर। आउटपुट पावर क्या होता है? आई स्क्वायर इंटू आर, आर मतलब RL, आई स्क्वायर मतलब क्या? IDC स्क्वायर। इनपुट पावर क्या होता है? इनपुट करंट स्क्वायर इंटू टोटल रेजिस्टेंस। इनपुट करंट क्या होता है? IRMS स्क्वायर इंटू टोटल रेजिस्टेंस क्या है? योर डायोड रेजिस्टेंस प्लस लोड रेजिस्टेंस। क्लियर? सी लुक एट द क्वेश्चन, ये क्वेश्चन है हाफ वेव रेक्टिफायर का, टू फाइंड आउट डिफरेंट पैरामीटर्स। क्वेश्चन पढ़ो पहले। A diode having internal resistance of 20 ohm, it is used for half wave rectification, and your applied voltage is 50 sin omega t, and your load resistance is 800 ohm. We have to find out this parameter like maximum current, DC current, RMS current, AC power input, DC power output, DC output voltage, and efficiency. I hope you can find out this one. So ये वोल्टेज का इक्वेशन क्या है? Vm sin omega t, right? Vm sin omega t. So this voltage equation is given 50 into sin omega t. So what is the value of Vm here? So the value of Vm is 50 volt, right? So Im क्या होगा? देखो मैक्सिमम करंट क्या है? मैक्सिमम वोल्टेज बाय टोटल रेजिस्टेंस। टोटल रेजिस्टेंस इज RL plus smaller. Capital R is given, RL is given here. Load resistance मतलब 800 ohm. So Vm कितना है? 50. Load resistance कितना है? 800. And diode internal resistance is given, which is 20. So you can get Im, right? So ये calculation तुम लोग करो, ठीक है? मैं छोड़ रहा हूँ, unnecessary time waste होगा। ये हो गया maximum current, right? So you are getting some value of maximum current. It is, let it be 50 and 820. 820 will be cancelled, 5/82, ठीक है। देन ये तो Im मिल गया। सो IDC का फॉर्मूला क्या है बोलो? व्हाट इज द फॉर्मूला ऑफ IDC? मैंने क्या बोला था? Im अपॉन पाई। Im तो मिल गया था अभी, देन इसका वैल्यू डाल दो, क्या मिल जाएगा? IDC। तो ये हो गया। सो IRMS का फॉर्मूला क्या है? मैंने क्या बोला था? Im अपॉन 2, राइट। Im तो इधर से मिल गया था, देन IRMS हो जाएगा। डन, दिस पार्ट इज क्लियर। नेक्स्ट इज, तो ये पार्ट हो गया, ठीक है। तो एसी पावर इनपुट क्या है? पावर इज, इनपुट पावर क्या होता है? इनपुट पावर इज नथिंग बट आई स्क्वायर इंटू आर, IRMS स्क्वायर इंटू टोटल रेजिस्टेंस। टोटल रेजिस्टेंस इज RL प्लस कैपिटल IRMS तो मिल गया था, वी गॉट द वैल्यू ऑफ IRMS। RL is given, small r is given, you can find out input power. Similarly, output power ये हो गया, AC input power हो गया। So DC power output क्या है? Output power is nothing but IDC square, I square into R ना, and here our output resistance क्या है? Load resistance RL, right? So IDC तो मिल गया था, RL is given, so you can find out output power. मैं कैलकुलेट नहीं कर रहा हूँ, अननेसेसरी टाइम वेस्ट होगा। यू कैलकुलेट एंड राइट द आंसर इन कमेंट बॉक्स। ओके, सो डीसी आउटपुट वोल्टेज क्या है? VDC का मतलब क्या होता है? IDC इंटू लोड रेजिस्टेंस। IDC तो मिल गया था, लोड रेजिस्टेंस इज गिवन, सो VDC मिल जाएगा, ठीक है। एफिशिएंसी क्या है आपका? आउटपुट पावर बाय इनपुट पावर इंटू 100, यस और नो? सो आपका आउटपुट पावर क्या है? आउटपुट पावर क्या है? IDC स्क्वायर इंटू स्मॉल कैपिटल RL, ये हो गया आउटपुट पावर। इनपुट पावर क्या है? IRMS स्क्वायर इंटू टोटल रेजिस्टेंस RL प्लस R। यू जस्ट कीप इन माइंड कि ये आउटपुट वोल्टेज जो मिल रहा है दैट इज coming across the load resistance, that's why output power is I square into load resistance. But if you talk about the input power, so it will be I square into total resistance. So here I square is IRMS square. I think it is clear. You can put the value and get the answer. Now we'll discuss about what is the efficiency of full wave rectifier. Efficiency of full wave rectifier, right? Again same thing, efficiency is nothing but output power by input power into 100, ठीक है। So output power क्या है? IDC square into load resistance which is RL, and what is input power? It will be IRMS square into total resistance, load resistance plus diode resistance. The total diode, total circuit resistance, total diode resistance. That may be two diode in case of center tap rectifier or four diode in case of full bridge rectifier. ये smaller मतलब कि total internal resistance of the diode, ठीक है। So now we can say IDC क्या है? IDC, what is the IDC here? Tell me. 2 into Im by pi, yes or no? Square into RL by, what is the RMS value? Im by root 2 square into how much? RL plus small r. Is it clear? So Im square will be cancelled. So your answer will be here, I think 4 by pi square in numerator into RL by, in denominator it is like 1 by 2 into RL plus small r, right? It is clear? So we can write here. So efficiency will be, I think it will be 4 into RL by pi square into 2 by RL plus small r. Okay, 2 and 4 is 8, so it will be 8 by pi square into RL by RL plus small r. Okay, so here 8 by pi square मतलब 8 by 3.14 square into RL by RL plus small r. RL is the load resistance, हमेशा याद रखना। ये total part is coming 0.812 into RL by RL plus small r. ये हो गया आपका efficiency, ठीक है। सो एफिशिएंसी मैक्सिमम कब होगा? ये एफिशिएंसी मैक्सिमम कब होगा? जब आपका इंटरनल रेजिस्टेंस कितना हो जाएगा? 0 हो जाएगा। सो इट विल बी 0.182 into RL by RL it will be cancelled. So efficiency is 0.182 into 100. So matlab 81.2%. Clear? So the efficiency, what you conclude from here, the efficiency of full wave rectifier is twice of efficiency of half wave rectifier. Yeah, that's my efficiency of full wave rectifier is nothing but 2 into efficiency of half wave rectifier. इसलिए मैंने बोला था हाफ वेव रेक्टिफायर का जो पल्सेटिंग डीसी का फ्रीक्वेंसी है, बट हियर पल्सेटिंग डीसी का फ्रीक्वेंसी 2f. I think it is clear. Okay, coming to the next question. So here it question is all about full wave rectifier. The load resistance of a center tap full wave rectifier is 1450 ohm and input voltage is given in terms of instantaneous equation, which is V is equal to Vm, 100 sine 100 pi t, right? So we need to find out peak voltage, RMS voltage, average current and efficiency of that full wave rectifier. And one more thing it is given, assume that the VI characteristics of diode having slope corresponding to resistance is 50 ohm. So here what part is given? Load resistance is given, which is 1450 ohm. And your diode resistance or internal resistance is given smaller, that is 50 ohm. Right? And input voltage is given in terms of equation V is equal to 100 sine 100 pi t. So as you know, the instantaneous equation of alternating voltage is Vm sine omega t, right? So here omega is 100 pi and Vm is 100. So here peak voltage is coming 100 volt. मतलब Vm is coming 100 volt. It is clear? Clear? So VRMS क्या है? फुल वेव रेक्टिफायर में VRMS का फॉर्मूला क्या है? V maximum upon √2. Right, B maximum already it is there, so answer is 100 upon √2. Clear? Then what is that it is given, what is the average current? Average current का formula क्या है? IDC or average current, you can say average current का formula is 2 into Im by pi, right, in case of full wave rectifier. So you need to find out Im. Maximum current is nothing but maximum voltage upon total resistance. Total resistance क्या है इधर? RL plus smaller. So RL is given, smaller is given, Vm is given. You can find out Im. So you put this value over here. You will be getting what? IDC or average current. It is clear? It is clear. Next, we'll find out the efficiency. Efficiency, as I've told, the output power by input power into 100. So output power क्या होता है? I DC square output current square into load resistance by input power क्या है? I RMS square into the total resistance which is RL plus smaller. So IDC तो मिल गया था which is I average, ठीक है? RL is given. IRMS कैसे निकालोगे? IRMS का फॉर्मूला क्या है? I max upon √2, right? So Imax कैसे निकालोगे? Imax is nothing but V max upon RL plus smaller by √2. So ये IRMS मिल जाएगा. So RL is given, R is given, so you can find out the efficiency. 100 multiply कर दो, efficiency आ जाए. ठीक है? So you solve it and answer comment box में लिखना. Okay? So I hope it is clear to all of you. What I've explained in this video, the half wave rectifier का definition क्या होता है? Like it converts S to DC. Different type of rectifier like half wave rectifier and full wave rectifier. Full wave rectifier again two type like center tap rectifier and breeze type of rectifier. In half wave rectifier you will having one diode. Full wave rectifier में दो diode हो सकता है, 4 diode हो सकता है. If it is 2 diode, that is called center tap rectifier. If it is 4 diode, that is full breeze rectifier, right? Then we discuss about what is the how to find out the average value or DC value of a half wave rectifier and RMS value of half wave rectifier. average value and DC value of full wave rectifier, RMS value of RMS current of full wave rectifier. Then we discussed about the efficiency of half wave rectifier as well as full wave rectifier, and we did some numerical. So last part, one small thing you remember. So if we get question like what is the advantage of full wave rectifier over half wave rectifier? The major advantage is हाफ वेव रेक्टिफायर में क्या होता है, अगर एफिशिएंसी जो भी मिलेगा फुल वेव में कितना मिलेगा, एफिशिएंसी विल बी ट्वाइस ऑलमोस्ट, राइट? एफिशिएंसी विल बी ट्वाइस। अगर हाफ वेव में पल्सेटिंग डीसी का, अगर हाफ वेव में पल्सेटिंग डीसी का फ्रीक्वेंसी इज एफ, फुल वेव में पल्सेटिंग डीसी का फ्रीक्वेंसी क्या है, 2f, right? So these are the advantages of full wave rectifier over half wave rectifier. Again, as I have told, full wave rectifier are two types, like center tap rectifier, okay, center tap rectifier बोला था, और क्या बोला था, ब्रीज टाइप रेक्टिफायर, ब्रीज टाइप रेक्टिफायर. So what is the advantage of ब्रीज टाइप रेक्टिफायर over center tap rectifier? What is the disadvantage of center tap rectifier? Center tap rectifier में क्या होता है ना, टैपिंग होता है, ठीक है? So a one transformer is there which will be tapped centrally, right? So this is not happening in case of bridge type rectifier. And bridge type rectifier में efficiency will be a little bit higher as compared to center tap rectifier, because ये voltage half हो रहा है, but here maximum voltage will be given, right? और क्या डिसएडवांटेज है, ब्रिज टाइप रेक्टिफायर में 4 डायोड है, अननेसेसरी यू आर यूजिंग 4 डायोड, इसमें 2 डायोड है. सो ये हो गया एडवांटेज ऑफ सेंटर टैप ओवर ब्रिज टाइप. ब्रिज टाइप में 4 डायोड है, सेंटर टैप में 2 डायोड है, ठीक है? तो सर्किट ज्यादा क्लमजी हो जाएगा. अगर 4 डायोड है तो इसमें 2 डायोड है, बट मोस्टली ब्रिज टाइप ऑफ रेक्टिफायर का एफिशिएंसी ज्यादा होता है एज कंपेयर टू सेंटर टैप रेक्टिफायर. ओके, so these are the things you should remember. So with this I am ending this lecture. So if you like my video, so please do subscribe, and comment box में comment भी लिखना है, so that I need to improvise. So thank you so much.